Okay, this is always fun information coming up here. Really, what this next section is about is looking at and developing an intuition for in which quadrants the sign ratio might be positive, in which quadrants might the sign ratio be negative, in which quadrants might the cosine ratio be positive or negative, in which quadrants might be the tangent ratio, in which quadrants might that tangent ratio be positive or negative. Let's take a look. So here we have our four different quadrants. Quadrants 1 on the top right, 2 top left, 3 bottom left, and quadrant 4 in the bottom right. Now, if we have, let's say we have some angle in standard position, and let's say that particular angle stops in quadrant 1. So here is angle theta. And let's say we have some corresponding point on that terminal arm, and you know, we could represent this as a right triangle with some hypotenuse, or we could say, you know, this just represents some radius on some imaginary circle that we could draw as well. So we'll just leave it by calling it R. So here we have some angle in standard position that lands in quadrant where the terminal arm lands in quadrant 1. All right, so what is positive for this particular angle? Is sine positive? Is cosine positive? Is tangent positive? Well, let's look at x and y. X here is definitely positive, and y here is also always positive. So if x and y are always positive, then what will that do to the ratios? Well, we know that the sine ratio is y over r. The cosine ratio is always x over r. And the tangent ratio is always y over x. And by the way, r is always positive. Or it's 0 in the particular case where you might have a point P at the origin, sort of that trivial, silly case. But otherwise, R is always positive. You might think about why that is. You might think about why R must always be positive, but really the key is in this relationship. R is really just the square root of x squared plus y squared. X squared is always going to be positive or 0. Y squared is always going to be positive or 0. Because even if y is negative, you square it, it becomes positive. Even if x is negative, you square it, it becomes positive. And so r will always be the sum of these two positive numbers, or in some cases x will be 0, or in some cases y will be 0. But in any case, and in this very uninteresting trivial case, if your point P is at the origin, then x and y are 0, but that's sort of an outlier. In general, outside of those specific cases, this will be true. And as a result, we have a sum of two positive numbers, and we take its square root, it's still going to be positive. So r is always going to be positive. X and y will change whether or not they're positive or negative, depending on what quadrant point P lands in. In this particular case, for quadrant 1, they're both positive. And so what can we say about the sine ratio for some angle that lands in quadrant 1? Well, the sine ratio should be positive, right, because we have positive y over r, which is always positive. The cosine ratio should always be positive in quadrant 1 because the x-coordinate is always going to be positive and the r value is always positive. The tangent ratio should always be positive because y will be positive, x will be positive. The quotient of two positive numbers is just a positive number. So for quadrant 1, we can say that the sine ratio and the cosine ratio and the tangent ratio are always going to be positive ratios. What about quadrant 2? What if we have some angle theta that has some terminal arm that ends in quadrant 2? Well, we can think about whether x is going to be positive or negative in quadrant 2. Just so happens that x is going to be negative and y is going to be positive. So let's think about these ratios again. So for quadrant 2, so we're looking at quadrant 2 now, this sine ratio of y over r, well, y is positive in quadrant 2, r is always positive. So the sine ratio is going to be positive in quadrant 2. What about the cosine ratio? Well, the cosine of this angle, we have a negative x-coordinate, and that's divided by a positive r value. So what can we say? We can say that the cosine ratio is just a negative divided by a positive, and if we have a quotient of a negative and a positive, that's always going to result in a negative. So the cosine ratio is actually negative in quadrant 2 because we have a negative number divided by a positive number. What about the tangent ratio? Well, for the tangent ratio, we have that same thing happening, right? Y is positive in the second quadrant. So y is positive in the second quadrant. X is negative in the second quadrant. A positive divided by a negative is always going to be a negative, and so the tangent ratio is also negative in quadrant 2. So let's list that information here. The sine ratio in quadrant 2 is going to be positive. The cosine ratio is going to be negative. The tangent ratio is also going to be negative in quadrant 2. So there we have it. That's the information for quadrant 2. For quadrant 1, for quadrant 3 rather, let's have some angle in standard position that terminates in quadrant 3, and so we have that associated terminal arm. Maybe there's some point on that terminal arm that we're interested in. Let's think about the x and y values of that point. Well, in quadrant 3, x is going to be negative. In quadrant 3, y is also going to be negative, right? We are below the x-axis, so that is where y has negative values. So let's look at quadrant 3 now, and what the ratios should be. Well, for the sine ratio, we're going to have a negative y value divided by a positive r value, so that's going to be negative overall, so the sine ratio is negative in quadrant 3. For cosine, we have a negative x-coordinate divided by a positive r value. Negative divided by a positive is a negative, so the cosine ratio is negative in quadrant 3. The tangent ratio, well, we have a y-coordinate that's negative, an x-coordinate that's negative. A negative divided by a negative is always a positive. So tangent is actually, the tangent ratio is always positive for an angle that terminates in quadrant 3. So let's record that. So we can say for an angle that terminates in quadrant 3, the sine of that angle is going to be negative. The cosine of that angle is going to be negative. And the tangent of that angle is going to be positive. And we only have one more quadrant to go. I know I'm going a little bit fast, but pause, rewind, and then rewatch if I'm going too fast and you want to see something again. But let's say we have some angle theta and it terminates in quadrant 4. We have some point on that terminal arm and it has x and y coordinates. Let's think about whether or not those x and y coordinates are positive or negative for quadrant 4. Well, for quadrant 4, x is always positive. That's where positive x values live. Right? They live to the right of the y-axis. So in quadrant 1 and quadrant 4, x values are always positive. For quadrant 4, well, the y values are going to be below the x-axis. That's where y values are negative. That's where negative y values live. And so let's look at what will happen to our ratios. Well, the sine ratio is just going to be a negative y value divided by a positive r value. So the sine ratio will evaluate to a negative number. The cosine ratio has a positive x value divided by a positive r value. And so a quotient of positive values is just going to be a positive number. And then for the tangent ratio, we have y, which in this particular case is going to be negative, x, which in this particular case in quadrant 4 is going to be positive. A negative divided by a positive is always going to be a negative. So the tangent ratio for some angle theta that terminates in quadrant 4, it will always be negative. So let's record that information here. So the sine ratio in quadrant 4 is negative. The cosine ratio in quadrant 4 is positive, and the tangent ratio in quadrant 4 is negative. This stuff you'll need to know really well. I encourage you to always try to logically analyze if you're doing some sort of calculation with some angle theta that terminates in quadrant 2 or something, and you have to find the cosine ratio, and if after you find it, you're thinking, okay, should I slap a positive or a negative sign on it? Just think about it logically. Well, if we have cosine just is the ratio of x over r, x happens to be negative in quadrant 2, so the cosine ratio should be negative. So I encourage you to always be thinking about why it is that the cosine ratio or the tangent ratio or the sine ratio might be positive or negative in a particular quadrant of interest. Before I ramble on too much, I'm actually just going to leave it at that, and I'll see you in the next video.